Hello, algebra students. Mr. Lawrence here, and we're going to be learning about scientific notation for the next couple of days. This should be a review, but I know a lot of you don't have it, so we're going to make sure you master it as well as my pre-algebra students have it, because I'm telling you, they got it, and they think it's simple. The main rule we want to follow in scientific notation is that we want our decimal number, we'll call it x, to be between 1 and 10. It can be equal to 1, but it cannot be equal to 10. It must be smaller than 10. So, in other words, I could have this as part of my scientific notation number. That could be the decimal portion. I could have this. I could even have this. I could not have this because it would be larger than 10, right? Okay. So I look at the 6,530,000 number. I know the decimal point's here. I need it to be here, right? Now, some of you are just going to go, oh, I'm going to move the decimal point. No, 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 no. Moving the decimal point is procedure. We are not moving the decimal point. We want to take this 6,530,000 number and make it seem smaller, easier to work with, right? Well, how could I turn 6,530,000 into a number between 1 and 10? In this case, it would be 6 and 53 hundredths, right? Because I want the decimal point to be here. Well, I could divide it by 10. Divide by 10. Divide by 10 again. Divide by 10 again. Divide by 10. Divide by 10. Divide by 10. Okay? But the problem is, if I'm supposed to give you $6,530,000 and I give you $6.53, there's a little problem there, isn't there? We can't just change a number because we want to. So to cancel out all that division we just did, we're going to multiply by a power of 10. What power of 10 do you ask? Well, how many times did I divide by 10? 1, 2, 3, 4, 5, 6. So what I'm telling you is that these two numbers are equal to each other. They are the same number in disguise, right? This is the version of it in scientific notation. This, by the way, we call standard notation. All right, so let's say we have this number here. Here's the decimal point now. I need it to be here. I want to turn, where are we at here? Million, billion, trillion, 487 trillion and a 4 and 87 hundredths. By the way, the decimal point will always be be after the first non-zero digit because I want to be between 1 and 10. Well, all that division, look, divide by 10, 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 divide by 10. I'm going to have to multiply by some power of 10. Well, I got 3, 6, 9, 12, 13, 14. So these two numbers are equivalent to each other. This one is in scientific notation. Okay. Let me see here. Let's go down. How about these? I've got these numbers that are smaller than 1. I see the decimal point, but I want the decimal point to be here. Well, to get that decimal point to move, I'm not going to divide by 10. I'm going to multiply by 10. So multiply by 10, multiply by 10, multiply by 10, multiply by 10, multiply by 10. Looks like I multiplied by 10. 1, 2, 3, 4, 5 times. So I have this 4 and 53 hundredths number. Now, another rule for scientific notation is, because I know some of you are so smart, you're thinking, hey, I'm going to divide by 10 to the, what do we say, fifth? Yeah, 5. Okay, but scientific notation is always written as multiplication. Always written as multiplication. So I'm still going to multiply by a power of 10, but in this case, I'm going to use a negative exponent. And if you remember from our earlier lessons in last unit, a negative exponent means to use the reciprocal. So right now, the black number and the green number are the same. right? They're equivalent. Um, this is the answer in scientific notation. I'm going to go off on a small tangent here. This negative exponent would mean use the reciprocal, right? So this problem would really be the same as 4 and 53 hundredths. It has a positive exponent, right? So it doesn't move. Divided by 10 to the fifth. And so for those of you that were thinking, hey, I should divide by 10, you're very intelligent, and that's awesome because that's exactly what it is. But to be in scientific notation, we always want to multiply by some power of 10. So in this case, we're going to use a negative exponent. Okay, so problem number 4. Again, I've got a number smaller than 1. I see the decimal point. I know I want it to end up here, right? Okay, and so I'm going to multiply by 10, multiply by 10, multiply by 10 3 times. Turning the, let me see, tenths, hundredths, thousands, 10,000s, 100,000, 621 hundred thousandths into 6 and 21 hundredths. But remember, scientific notation, we have to multiply. And so we're going to multiply by a negative exponent, 10 to the negative exponent, which is really division, isn't it, in disguise. Isn't math crazy? Because this number, this black number, this number here, and this number are all the same. Okay? I wrote it out as 1,000. I could have written it like this. They're all the same number, right? There you go. So you see the negative exponent. Use the reciprocal, same as 1,000. They're all the same. Scientists, math people like to use this thing called scientific notation to deal with really big distances and really small numbers as well. We'll talk about that a little bit in class tomorrow. Okay, now, by the way, how do we go the other way? How do we go from scientific notation? Well, if I'm multiplying by, to standard notation, I'm sorry, if I multiply by 10 to the 7th power, that's going to be 745, right? Okay, the decimal point is right here, right? Now, I'm not going to just add zeros on. I hope you're not thinking that. Oh my gosh, I'm going to cry if you are. We don't just add zeros. We're going to multiply by 10 7 times. Each time we multiply by 10, the decimal point is going to move. So we're going to move it once, multiply by 10 again, 2, 3, 4, 5, 6, 7. So the decimal point's going to be there. I'm going to fill in those open waves with zeros, and my new number in standard notation, it's actually not a new number, it's the same number, is going to be 74,500,000, right? All I did was multiply by 10 7 times. Okay, what if I have a really small number like this? Well, I'm going to, oops, I'm sorry, silly me. What if I have a number like this, which is really division, isn't it? Because I'm multiplying by 10 to the negative fifth. It's really this number. If I had $1.43 and I had divided amongst 10 to the fifth people, they wouldn't get very much, would they? Maybe a piece of a penny. It's really, I got too many zeros there, don't I? One, two, no, I'm good. It's 100,000. If I had a share of $1.43 with 100,000 people, we wouldn't get very much. So this number is going to get really small. So I'm going to multiply this out, but actually I'm going to divide it out because of the 10 to the negative fifth. It's like division. So I'm going to divide by 10, 2, 3, 4, and 5, right? 0, 0, 0, 0, and there's my new decimal point. My new number, or the new position of my decimal point, my new number is 0. And then there's a decimal point, 4 zeros, and a 143. So that's going to standard notation, right? It's actually more intuitive because you're just multiplying or dividing. All right, so let's get back to what we were doing here. Now, do you know how to multiply the quantity of 3x to the fifth times the quantity of 2x. Um, for some reason, I have an extra symbol in there. 2x to the third. Sure you do. You're going to multiply the 2 times the 3, get 6, and you're going to multiply the x to the 5th times the x cubed, and you're going to get x to the 8th. And there you go. Look at how simple that is. Well, it's the same problem in scientific notation. This 10 to a power behaves like a variable. It's a base to a power and a base to a power, and they don't have to match. They just happen to match in this case. Most of them won't match. I'm going to multiply 2 times 3, and I'm going to get 6 times, and 10 to the 5th times 10 to the 10th. Wouldn't that be, excuse me, 10 to the 5th times 10 to the 5th? Wouldn't that be 10 to the 10th? And there you go. I should check and make sure that my decimal part of my number is in scientific notation. Is that 6 greater than or equal to 1 and less than 10? Of course it is. So this is done. Okay, number 6. Sorry about that, just bumped my headset. Number 6, I'm going to multiply 7 times 8. Well, that's a hard one. We better get our calculators. 56. And then I'm going to do 10 to the 4th times 10 to the 9th. Well, how many 10s are being multiplied? 13. Now, when I go to check to see if my decimal portion is between 1 and 10, I notice it's not. So I'm going to have to adjust it. I know the decimal point's here. I'm going to have to divide 56 by 10, right? That'll turn it into 5 and 6/10. But if I divide this side by 10, I'm going to have to multiply this side by 10 because I have to cancel out the division. Otherwise, I change the number. Some of you might have been thinking, oh, divide by 10 again. Well, if I divide by 10 once and I divide by 10 a second time, I've just divided by 100. I don't want to do that. I want the number to stay exactly the same. So I divide the decimal portion by 10. I have to multiply the base exponent part by 10. It's an inverse relationship. If I divide the decimal, if it gets smaller, then the exponent has to increase. Okay? The opposite would be true. If I had to multiply the decimal, then the exponent would decrease. It's an inverse relationship. Okay, so now I'm going to multiply 8 and 1/10 by 7 and 8/10. And off the top of my head, I don't know that, but I'm not afraid to multiply. Let's see here. In fact, I like to multiply differently. I like to get 8. I like to get 64, and 7 would be 71, and then 56 and 7 would be 63. And so there is my decimal, 63 and 1800ths. I can show you how I did this. I can, when I practice, I can do it in like 2 to 3 seconds. Way easier than the more standard algorithm. All right, now I have to multiply my powers of 10. Well, if I have 10 to the negative third times 10 to the ninth, wouldn't that be 10 to the sixth? And for those of you not believing me, let's do it this way. Uh-oh, I have a negative exponent. I better use the reciprocal. That would be 1 over 10 to the third times 10 to the ninth, which could be written like this, 10 to the ninth over 10 to the third. Wouldn't there be 9 tens? All being multiplied? And then there's 3 tens down here. And these 3 tens would cancel with 3 of those tens, leaving 1, 2, 3, 4, 5, 6 tens being multiplied. The problem is this number here isn't between 1 and 10. It's too big. So I'm going to have to divide it by 10. But if I divide the decimal portion by 10, I will multiply that portion by 10. So now I know Gotham's going to ask me, well, what happens if you have to divide it by like 100 or 1,000? Well, then you would divide by 100 or 1,000 on the other portion of it. Yeah, because it cancels each other out. All right, 6381 times 10 to the 7th. And there you go. All right, I think I got one more example here. Oh, looks like part of my problem got erased. Oh no. Let's do a 12 there. All right, I'm going to divide in this case. So I'm going to divide these two numbers. And off the top of my head, I'm thinking it's going to be 3 something. There's going to be a 3, no, 15. It's going to be a 45. There's going to be a 45 involved in here, I think. But let's see. Okay. So we're going to divide by 5, and 5 is going to go into 24 times. Okay. Going to subtract 25. Yep, there's the 45 I was talking about. It's actually 45 hundredths. All right, so I've got this 45 hundredths going on. Now I'm going to divide these. And remember, scientific notation is always multiplication. I'm going to get 10 to the negative fourth because it's 10 to the eighth divided by 10 to the 12th, which would be the same as a 1 over 10 to the fourth in the denominator, which I could write as 10 to the negative fourth, right? I could use the reciprocal and change the exponent. Yeah, I can go the other direction. Problem is, this number is not in scientific notation. Looks like I'm going to have to multiply it by 10 to get the decimal where I want it. If I multiply by 10 here, I'm going to uh, multiply by 10 to the negative first there, right? This is going up. This exponent is have to go decrease. You could think about it as dividing by 10, but I thought the negative exponent might be easier. So we'll have a 4 and 5 tenths, and then we'll have times 10 to the negative fifth. And there you go. Piece of cake. All right, we'll get some practice with that in class tomorrow. Mr. Lord signing off. Good night, everybody.